So my name is Anna. I'm a senior front-end engineer at GitLab. We've got pretty much covered here with two speakers and an amazing lightning talk. So GitLab is an open source end-to-end software development platform with a huge team of more than 1,800 people and over 30 million registered users, as well as a giant code base with a lot of tests. Who have ever heard about GitLab before Natalia's talk and Andrew's lightning talk? Oh, it's nice to see. And do you use GitLab in your day-to-day work? Oh, amazing. I'm happy to see. So GitLab is one all-in-one DevSecOps platform that empowers development, security, and operations teams. GitLab provides a comprehensive set of tools and features for the application's full lifecycle, from project planning to collaborating on code creation, verifying code quality through automated testing, packaging applications into containers, deploying them to various environments, and continuously monitoring and optimizing application performance in real-world usage. I'm a member of the Deploy Environments team, this part. Our main goal is to get a coded, integrated, and built software application into the hands of users smoothly and securely. We simplify and automate the deployment process by allowing our users to define their infrastructure as code, ensuring that the application's infrastructure is well managed. Our team specializes in streamlining the process of moving code between different environments, whether it's transition from a testing environment to production or to any other staging area. We also offer clear visualizations of these environments, allowing our users to track deployments and monitor their health of the applications effectively. Our focus is on reliable and efficient delivery, all while maintaining a strong dedication to safety and continuous improvement. As a front-end developer, my goal is to create clean and well-maintained interfaces to visualize complex data for the deploy stage. One of our team's main priorities is the development of a comprehensive Kubernetes dashboard, empowering our users with a dedicated tool for seamlessly monitoring their Kubernetes clusters, eliminating the need of third-party software. Do you use Kubernetes in your work? Oh, cool. We have a person who actually uses Kubernetes in work. Yeah, I would say that Kubernetes is an amazing tool, but probably this conference is not the best place to search for developers who uses Kubernetes in their day-to-day work. But I'd like to discuss it just a bit so that we all have the context for the next slides and the rest of my talk. So Kubernetes is a powerful open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications. It simplifies the complexities of container management, offering features like load balancing, automated scaling, and self-healing. With Kubernetes, users can deploy and manage a multitude of containers and microservices across clusters. Did I sell it to you? Okay. I'm not working for Kubernetes, so that's fine. I will try to sell the dashboard for you at least. Kubernetes support and integration is one of the top priorities for my team. The Kubernetes dashboard serves as a user-friendly web-based interface designed to simplify the complexities of Kubernetes administration. It offers a visual and centralized way to monitor, troubleshoot, and manage applications and resources in Kubernetes clusters. Whether you're a developer, operator, or administrator, the Kubernetes dashboard is a crucial tool that provides real-time insights and simplifies the deployment and administration of containerized applications. I will use the Kubernetes dashboard as our real-life example during the talk. It is currently in a very early stage, so early that you will be the first people to ever see it. Let's start our exciting journey into the world of dashboard development. During this talk, we'll dive into the challenges of building complex dashboards. Then we'll become the design detectives, uncovering the secrets of the layout and detecting reusable and unique components. Moving forward, we'll cover how to create and refine common components in an iterative and efficient way. Lastly, we'll embrace the dashboard's heart and soul, the data. We'll go through the third-party APIs, mastering the art of managing the data they return. Let's get started. Building a complex dashboard can present various challenges for a front-end developer, such as data management, performance optimization, real-time updates, data visualization, user experience, scalability, and maintainability. What would be our main goal? Probably to create an easy-to-use, well-organized data visualization, ensuring a smooth user experience. We should also focus on maintainability, so that our future selves can easily provide updates and scale the project, because we all know who is going to maintain this code. Let's see some examples. Does this dashboard look like a good dashboard to you? Thumbs up, thumbs down? What do we think? Yeah, pretty good. Let's look closer on it. It presents the information in a well-structured and clear way. The color scheme is balanced and easy to navigate through. It handles the user selection by having a clear state indicating the piece of information currently in focus. While it has 4 blocks of data full of numbers and different graphs, it doesn't overwhelm the user with the amount of information and looks pretty clean. I would say it looks like a good dashboard. Of course, we couldn't know if it handles its data efficiently and if it's easy to maintain or scale it. Let's assume the best, shall we? Here is another example. Is this a good dashboard? Thumbs up, thumbs down. Yeah, this poor little website is a real one. It tries to serve its purpose, and it actually works fine. And it is featured on every article you can find about bad dashboard design. So it's pretty famous. It contains way too much data. I think it's the main problem here. It tries to fit everything it can into a single screen, which makes it look cluttered. It is very bright and colorful, but it doesn't look like the color scheme is concise and balanced. It also has a kind of an uneven layout, which makes it difficult to quickly scan with a glance. Some of the empty blocks are there actually because their data just won't load correctly. It seems like this dashboard will be harder to maintain. So, what can we do in order to create a good dashboard? Building a good dashboard is not just about the data it contains, but also how the data is presented. A well-structured and engaging dashboard is one that not only conveys information efficiently, but also makes the user's experience intuitive and satisfying. A good dashboard is interactive, allowing users to explore the data, uncover insights, and take action. To achieve this, we need to consider the layout, the choice of data visualizations, and the overall user interface. A well-structured dashboard should have a clear hierarchy, ensuring that the most critical information is readily accessible. We also want to minimize clutter, focusing on what truly matters. It is essential to highlight the interactive state of the elements, such as hover, focus, selection, data filtering, and others. Basically everything the user can do with the data we are presenting. We should provide a seamless experience for the users, so that they can easily distinguish and interact with the elements of the dashboard. By effectively highlighting these states, we improve user experience and engagement. It's all about guiding the user's attention and providing clear feedback. Developing reusable blocks is a fundamental aspect of efficient dashboard development. It simplifies data management by allowing us to create components and structures that can be used throughout the dashboard. This approach saves development time and enhances maintainability, and I'm really worried about this. When updates are needed, we make them only once, and they apply uniformly across the dashboard. Reusable blocks provide consistency, reliability, and ease of data maintenance. Keeping in mind our goals and the principles of a good dashboard, let's now return to our example, the Kubernetes dashboard. As we shift our focus to the dashboard design, we'll dive deep into its layout, structure, and visual elements. We'll break down the components, explore how information is organized, and identify strategies for the development. So, how should our Kubernetes dashboard look and feel? It is over 24 pages of the cluster data. All the data should be accessible, filterable, and clickable. There should be a way for the user to dive deeper, interact with the data, and explore detailed views effortlessly. The dashboard should have convenient navigation. It should provide real-time updates. To sum it up, the Kubernetes dashboard should offer a dynamic, real-time view of the application state and resources. Now, let's break down the design and create an actionable development plan. First, let's note the common layout building blocks here. These are the foundational components that we'll only create once and then seamlessly incorporate into every page without any customization. In the current example, we can see that the breadcrumbs, the agent section, and the filters are instances of these common blocks. The other layout building block type is the reusable blocks. These are the components we have on every page, but they do require a bit of customization, as they should reflect the current context of the app. This is page title and the navigation sidebar, which should indicate the current page. We will create these elements only once as well, but we will need to ensure the current application state is properly reflected. Now let's turn our attention to the specific content, the heart of our dashboard. This is actual page content, the unique and most valuable data for each dashboard page. This part of our dashboard is where the magic begins, where data is transformed into actionable insights. So, as we develop our dashboard, keep in mind that this is the section that provides the most value to our users, and it should be both informative and user-friendly. Now that we analyze the designs and grasp the scope of the tasks, let's get into the actual development. Building a dashboard based on complex third-party data is not an easy task. In order to deliver it successfully, we need to properly break down the work into manageable chunks, master the art of iteration, and maximize efficiency by writing as little code as possible while heavily relying on common and reusable components. As much as I would love to deliver the fully dashboard all in once, I believe it would be even more efficient to do it in a number of iterations. My proposal here is to stick with the page title and the agent status area, which will be common block, and the router view to present the unique data. This way, we are reducing the scope of the work dramatically while delivering the most valuable parts of the interface. This is how it will look like for now. Pretty manageable. Let's start by creating a router. We use Vue router, the official router for Vue.js. It deeply integrates with Vue.js core to make building single-page applications with Vue.js a breeze. In this code snippet, we import and register Vue router as a plugin, allowing the application to use routing functionality. Then we export the create router function, which takes the base as an argument. Our dashboard is integrated into a bigger GitLab app, So we need the base path for the router to work properly. Then we provide the history mode. This means it uses the HTML5 history API for routing, allowing for clean history-based URLs without the hash symbol. And finally, we define our routes. Each of them is an object defining the route's name, path, and component to render. Here I also added a meta property that defines the title of each page. It is a simple way to access information on route locations and navigation guards. Do you remember the page title part we defined as a reusable component? This information will come in handy for the title component we're going to build. Now when we have a working router, we'll need to create the main layout for the first iteration. According to our plan, it only has a page title component containing common information and a router view to show the page-specific data. While we simplify the desired dashboard layout quite a bit, we can still deliver the minimal feature set. This is the default method of development in GitLab. It works well for us, as it gives us the possibility to get feedback as early as possible and reconsider the next steps if needed. We'll absolutely need the sidebar with the navigation and the breadcrumbs, but the main value of the feature in its early stage is the layout and the data itself. An iteration should be planned in a way that's easy to proceed or to revert. Keeping this in mind, we don't want to overwhelm the main app component with the logic. We'll create a separate component for the page title as it's a common element, and the only thing changing there would be the title value itself. Later on, we can easily add other common elements in the layout and get it immediately working for all the dashboard pages. The router view element is where the content of each dashboard page will be dynamically rendered. So we prepared and prepared. Now it's time to start creating. The title component consists of two parts, the title itself and the agent's data. The agent, or GitLab agent for Kubernetes, is the key to connecting to the Kubernetes cluster and getting the information from it. We will talk a bit more about the agent later, when we'll get to the part of actually receiving and visualizing the Kubernetes cluster data. We have a couple of points to cover here. Firstly, what data do we need? We need the title, and we already know it's coming in the props. The agent's data we're going to get from the GitLab backend. Now let's plan which elements should we use. For the page title, we need to use some kind of heading element, and I think H1 should be semantically correct. For the agent data, it's an icon and a link. And finally, let's define which elements can be reusable. As we are talking quite a bit about reusable components, let's discuss what a reusable component actually is. A reusable component is a special chunk of code that has its purpose, better to be a single purpose. It can be a button with a purpose of performing some action on click. It can be an icon that takes care of being visually consistent with other icons. Or it can be a drop-down, the goal of which is to hide and show some content. So it should be rather simple. Also, the reusable component shouldn't be too simple. For example, we might not want to create a component for the title element when we can just use an appropriate HTML tag. A reusable component should be neutral and independent from the context, as we want to use it in different scenarios. The button can serve its purpose being a part of a form or a banner or a modal and doesn't need to care about its parent component. Usually, a reusable component should be customizable. It is quite rare to have a component that would be reused exactly as it is. We don't want to create separate components for success and warning icons, while all the logic remains the same. We'd rather add a possibility to customize the icon's type so that we can easily reuse it in the future when we'll also need an error icon, for example. And the most important thing about a reusable component is that it should be used more than once. In our case, we can be pretty sure we'll need another link or icon for the dashboard. At GitLab, we have a design system called the pajamas. It has its name as it's cozy and comfortable, just like working from home in your pajamas. The pajamas design system is the single source of truth for everything anyone needs to know about contributing to GitLab. We will rely heavily on its components during the whole dashboard development experience. Now we start by incorporating the GL link and GL icon components into the title section. The GL link not only ensures all the links look good and function flawlessly, but also adds a layer of security to our links. It keeps our cluster information in perfect harmony with the rest of the product. The GL icon component is used to render any SVG we have within the GitLab's icon sprites. In our example, within the Add and Connection section, the icon is purely decorative, and its removal won't affect the user experience. Therefore, the GL icon component will hide it from the screen reader for us, ensuring a more accessible and streamlined experience. The GitLab UI library also provides us with a handful of utility CSS classes. It covers a lot of cases, so the chances are pretty high you won't need to write a single line of CSS. These are all the classes starting with GL in my previous example, such as GL display flex, GL align item center, GL margin left 4, and others. The great advantage of the GitLab UI is that it is well tested and highly maintained, which makes it reliable and can save us so much time and effort. Returning to our dashboard now. We have already created the layout that will be used across all the different pages. Now it's time to shift our focus into presenting the individual page content. Usually, we won't have the kind of dashboard where each and every page is so unique it has no visual overlap. That's why we want to start by finding common patterns. Identifying these patterns is not just about efficient planning and estimating, it's also a time-saving strategy. The screenshot is from the pods page. How many different components can you spot here? Any ideas? Okay, I hear 3, I hear 4, I hear 5, and that's all correct. And the answer is only 2. The main parts. As we explore the entire design, we notice that every page features at least one of these components, each filled with a different set of data. Now let's uncover customization possibilities. A quick scan reveals that we could have varying sets of stats, anywhere from 2 to 5 stats, always appearing in the same row. The labels could be one of running, pending, succeeded, failed, or ready. And then there is a table where data can vary, but each column can be presented in just 3 ways: a text, a badge, or nothing. With this foresight, we can predict the elements we need and how to best present data within these elements. Finally, let's see what states can the data have. In this example, we can predict that it can be loading, it can be fully loaded, or it can be nothing to show, empty. We'll need to handle those. And let's not forget user interaction. Our first iteration might include features like sorting data in the table by each column or loading the next page if there's a lot to explore. Here's the example layout we can use on each page. It will ensure consistency around all the views. It can handle the dashboard page states such as loading, error, empty, and data. With this component taking responsibility for all the data presenting, each page can focus on fetching and transforming the data. Here we are using some of the GitLab UI elements. The loading icon, which creates a pure CSS spinner, the alert to communicate an error to the user and provide the next steps, troubleshooting actions, or links to learn about or remedy the event that triggered the alert. The empty state serves as a placeholder when no content exists on a page. There are some custom components as well here. The workload stats component creates a flex container for the individual stats that are driven by the GitLab UI GL single stat component. We can handle the layout and ensure the responsiveness of the elements using the GitLab utility classes. This component requires zero context. It can render as many stats as it gets with any value and title provided. The workload table component is a bit more complicated. It is also a contextless component that accepts any fields and items to generate the table. The GL table component provides a variety of slots for custom data rendering. As we've noticed before, most of the cells contain text data which doesn't need custom handling. But the status component contains a badge that highlights the specific element status. And I'm sure you were counting the badge element when I asked you about the reusable components there. So we can create a specific template for the status field, which will display the data in a slightly different way. It will use the GL badge component that provides a handful of variants such as neutral, info, success, danger, and others. We'll create a list of possible combinations for status value and its badge variants, so that we know that the succeeded status is always displayed as success, failed status is always displayed as danger, and running status as info, and so on. The workload table component also adds the pagination for our table. Using the GL pagination, we can easily achieve it by letting it know what's the current page and emitting an event on page change so that the next portion of data gets fetched. And just like that, we created ready-to-use layouts needed for the first iteration of the Kubernetes dashboard. These layouts provide a strong foundation, making it effortless to add new pages. Each new page will only need to focus on data retrieval and processing. Our current set of the UI components covers all the standard pages, offering an auto-updated page title, essential information about the GitLab agent, and specific data presented as stats, and in more detail as a table. The layouts are capable of handling various types of data, ensuring a consistent and seamless user experience throughout the product. My slide says that we've reached the final result, but do we actually? So what should be our next step? Do we still lack something for this dashboard? Yeah, I believe we do. We need to bring life into it and make it truly functional by actually showing some data there. So we need to connect it to the real data sources. While each dashboard is unique in terms of the data to fields of use, our goal remains consistent: to efficiently retrieve, process, and present this data. We'll need to interact with some kind of an API, manage the application state, and ensure the data flows seamlessly into our layouts. This involves designing data models, setting up requests and responses, and handling potential errors or exceptions. Additionally, we need to implement real-time data updates to keep the dashboard current and responsive to changes in the underlying data sources. This phase is where the dashboard truly comes to life, providing users with accurate, up-to-date information and a great user experience. The Kubernetes dashboard is an interesting example to look at in terms of data handling. When we talk about data, we're referring to the information that populates the dashboard, such things as cluster stats, workloads, and other details. Now, here's the interesting fact. For the Kubernetes dashboard, we don't have our own special data sources. Instead, we connect directly to the Open Kubernetes APIs. It's pretty cool, because it means that the data we get is as accurate as it gets, because we get it from the source without any modification layer. On the other hand, integrating third-party APIs in a safe and reliable way is challenging. Do you remember I promised to tell you about the GitLab agent for Kubernetes? The time has come. The agent plays a crucial role in the whole Kubernetes experience within GitLab. It is a secure bidirectional connection between a GitLab instance and a Kubernetes cluster. The feature consists of two parts, the agent key and KES, Kubernetes Agent Server. The agent key gets installed into the Kubernetes cluster. It keeps the connection to a KES instance and proxy KES requests to Kubernetes API. It may also actively send information about cluster events to KES. While agent key is actively communicating with cluster, KES, on the other hand, represents a GitLab server-side component. KES performs the authentication for the agent key and accepts its requests. So the agent key can talk to the cluster and to the KES, while KES can talk back to the agent key and to the GitLab instance. This is how we get direct connection from the GitLab frontend to the Kubernetes cluster. As you can see, there's some serious magic involved. In order to utilize GitLab agent connection to Kubernetes from the frontend, a client of any kind is required. Initially, we were looking into official Kubernetes JavaScript library, but unfortunately, it is not currently supported on web browsers, as it is intended to be used within a server-side environment. It actually has a feature request to be supported on web browsers that is stale for a couple of years, so we don't have high hopes there, and we decided to not wait for another couple of years, and developed our own library that is specifically designed to work in a browser environment. The GitLab Cluster Client Library simplifies the process of retrieving information from the Kubernetes API endpoints and executing commands. We also integrated this with the Watch API, which allowed the client to receive updates on cluster changes as they occur, eliminating the need for frequent endpoint polling. This significantly improved the performance and efficiency of the Cluster Client Library. The library provides a way for handling the authentication and authorization. The development of the Cluster Client Library has allowed us to overcome the limitations of the official Kubernetes Client Library and provide a smooth and efficient integration experience with GitLab and Kubernetes. With that library and our ongoing efforts to improve it, we are committed to providing the best possible experience for our users in managing their Kubernetes clusters through the GitLab UI. Notably, the library has achieved over 42,000 weekly downloads from NPM, which is pretty good in my opinion. Here is an example how we can use the GitLab Cluster Client Library to access Kubernetes pods data. We can provide the configuration object containing the necessary info, such as the agent ID, authentication method, request headers, and others. It provides a dedicated method for each Kubernetes endpoint. These methods are auto-generated from the Kubernetes Open API. The GitLab Cluster Client Library provides the full Kubernetes data in a clear and structured way. Our team has recently added support for the Watch API, a feature that allows clients to watch for changes to resources in a Kubernetes cluster in real time. This way, the cluster can establish a long-lived connection to the API server and receive a stream of events related to resource changes. This can be added, deleted, or modified events. In the example, you can see the interface reflecting a recent change. I hope you can see it. Yes, it's moving. So the history behind it is that I do have a cluster, my local cluster. It has just 4 pods, so it's a small cluster. And in order to impress you all, I just deleted all of the clusters and relied on the Kubernetes to heal itself and recreate the pods for me. So we can see the process. It's an actual GitLab UI that we are watching, a little piece of it, which I'm really proud of. So we can see the process of recreation as some pods appear as pending and eventually update to running state. So this animation is it's just in a loop. So I won't usually come and remove all my pods every 30 seconds, but I just wanted to keep it moving. The Watch API support provides a way to maintain accurate and up-to-date information about the cluster state, which is essential for the Kubernetes dashboard. It was a pleasure to share this fresh and exciting feature with you all and have a chance to discuss it while covering the main principles of the efficient dashboard development. Please rate my talk, and thank you.
Well, thank you very much. That was fantastic. So I wouldn't be at all surprised if we have some questions. Anyone wanting to dive deeper into, say, the penguins, or maybe some complex data, or how it all fits together? Yes, we have a question just here in the middle.
Thanks for the talk. So I have a question which is semi-related. You showed us an iteration 1 and we identify common components. Now maybe Kubernetes isn't the best example, but normally when we develop, new patterns will emerge and we might find some new common patterns. Do you have any tips about how to do that? Like when to realize something will become a new common component or pattern or something like that?
Thank you. That's a very good question. So working iteratively also helps us to get immediate feedback and to move our direction if something changes. And usually it does change. So here I showed you 24 pages of the designs related to the Kubernetes cluster stuff. And I'm pretty sure next week we'll have something else appearing there. And we can just trust our best judgment here. So some of the components, like the table, you can be pretty sure you will have another table. And the badge, like it's pretty basic things that you will definitely reuse. And I would say that you can keep this updating. And if you realize that you keep copying the same code, it's probably a time to create a reusable block from it. And on the other hand, when you realize that you keep popping this ifs, so it's time to do some separation here.
I have a question from the people watching online. I'm here so you can read it as well. How would you integrate a Vue.js application with Kubernetes to ensure scalability and reliability? Share your approach in deploying, managing, and scaling Vue.js application within a Kubernetes cluster, considering factors like containerization, service discovery, and communication between microservices. It's a bit too much, maybe.
It's a bit of a complex question.
So let's skip to the first part. How would you integrate a Vue.js application with Kubernetes to ensure scalability and reliability? It's a bit too much.
Yeah, that's a good question as well. It's pretty complex and pretty specific. I just couldn't create a strategy out of my mind on how the best approach would be to deploy your application using the Kubernetes. But it is definitely a doable thing, and it's also a nice idea. And if you need scalability, and it is a really good thing that you are looking into the Kubernetes right now and its features. So if going a bit closer to the dashboard that I was presenting, it is also a huge part of our analyzing the complexity of this work, as there could be a huge cluster. It could be like I have 4 pods, people have thousands of pods. And I don't want to have thousands requests and just overwhelm my browser and show nothing. So we did plan on it. We did plan throughout the pagination and the proper amount of data we want to show. So we want to paint the first meaningful impact, getting a chunk of data, and then we subscribe to the events of this data so that we can keep updating. And updates are just going one by one. So it's not like thousands of pods are coming to me one time. So this is how I prevent my page from crashing. And this is most definitely not the thing that the person was asking for. But I did as much as I could here.
Thank you.
Great answer. Ed, any other questions? Someone else might want to ask something? No? Well, thank you so much for a great talk. And could we give another round of applause to Anna?
Thank you.